Hello all and welcome to one of my LinkedIn events. Trying something new this time. I don't know if you follow any of my blogs on my website or that I publish every now and then, but one of the categories I have is called Hot Tech, and I thought I'd use one of these to share my experience and with this hot tech, which today is on graph databases explained. So, what are they? How do they work? What are they good for? Joining me today are also two folks from Neo4j. They're a graph database platform provider, probably the world leader in it, and they will actually probably do most of the talking today. And they're the ones who can answer all the tough questions. So, why don't we get started? So again, a bit about me, and this is all the advertising I do. As you see, my website in the bottom left there has all the information about me and how to contact me. My background is I was a consultant. I worked for a large software company, and then I've also been in industry with very often having architecture team, and my last role was chief architect for a very large global manufacturing company. And now I am an independent consultant and do things like this. So if this resonates with you or you have more questions, feel free to reach out. In this case, what we're doing today, you might want to reach out to Neo4j. So what we'll discuss today is the new technology and some use cases of graph database technologies. I'll give a quick example at Caterpillar where I was, and then Neo4j will give a lot of other examples. In this workshop, we'll cover what a graph database is and a graph platform, use cases, and then why these graph data platforms make these use cases so much easier to execute and enable. And like I said, I have Neo4j with me here that we'll do the core of the presentation and discussion, and we'll be able to answer any questions you have. So let's get going. Let me advance here. So I always like to start with definitions. Graph database is a database that uses graph structures for semantic queries with nodes, edges, and properties to represent and store data. So again, a little bit of a jumbo mumbo for me, but I always like to go to Wikipedia to find out what things are and their definitions, and what you want to kind of look at specifically is these things that have they talk about nodes. So why don't we start with that first? Which are really to me those are database objects. Like I'll give some examples with they could be people. And this, if you were to represent a family tree, they could be family members. So they're people, but one's, me, one's my dad, my brother, sister, nephew, niece, whatever. And then there are edges, which really are relationships. I don't know why they use the term edges, but those are the relationships. So the arrows between that you see here between these individual nodes, and in that case, and they have directions, as you can see. They have arrows that go in one direction or the other. So I would be, my relationship to my father would be, he's my father, and the other way around, it'd be that person's my son. So the direction changes the type of relationship we have. So that you can kind of see how that works with a family tree. And then there's properties. So I think here represented, they might have things here like, I think it has age or something. It might be talking about people. So, and again, in this people example I'm using, I could use my age as one of the properties, my age, my height, my weight, all those things. So information about the node. So, and the secret sauce really are these arrows, the edges. So what makes graph databases different is that they are good at finding information and do analysis around relationships. So that's key to keep in mind. Okay, if I go to the next, I'll give you maybe a quick example of we just talked about people, how their relationships, they could be a boss, employee, customer, vendor, repairman, and so on. I'll give from last place I was, I'll give a kind of bill of material, which is a relationship between what are components into what parts and so on, and what assemblies and which finished products. But you can do more with that. So one of the big things that if you're a complex manufacturer that goes through maybe a dealer network like a car manufacturer would, or Caterpillar where I was, you might have a bill of material which, you know, is kind of this stuff. This is an assembly of that, and you get properties in those, and they have relationships. I go into that, and this part goes into that subassembly and so on. So that's kind of relationship. So you can think about there is the engineers who create a bill of material, which is the ideal, and it might give you options of what you can actually do. So it might say, you can have this, this are the different options. So you pick one of them that go into this subassembly, and then this other component. But you have options what to put in. Then when you actually go and you go at the manufacturing, call it BOM, or we like to call it as built. So the way it was built in the factory, it'll tell you, oh, it used this component and these others weren't. And then to get the people aspect of it, you could track, oh, and by the way, this was assembled by this person. Okay, and you can track all these relationships. So let's stick with this. You could start seeing that, wait a second, when this person assembles something, that serial number part out in the field seems to have a lot of trouble. Oh, maybe this person's not doing something right in the assembly. I'm just making something up. But you can see how you can, the analysis then is on the relationship of these things, and how and they're getting an analytic information about the relationship between them. Oh, it's this builder versus this other person on the production line. Well, they have differences when they make things. What's the difference and why, and does it have any consequences? Then you have the sold bill of material. So it could be that if you go through a dealer network, they might, if this is your bill of material here, let's say, they might add something on here. They might do some sort of a add component or something. Maybe they put in an extra attachment to the machine or something like that. Or they might actually say, you know what, no, we're going to take this off and give you leather seats. I don't know. And then you can keep, again, the relationship of, well, who did that work and what's there now, and you still have the original work and when this was removed. So people see, oh, over time this thing changed, and this is what changed. And then there's the out in the field, or we call this as serviced. You might be doing repairs. Who repaired it? Was it done by a specific dealer? Was it done by a service technician from Caterpillar? Which one? And then you can say the part was it's not a regular part, it's a add-on, it's a repaired part, it's a replaced part, and all these end relationships you can imagine, you can do all kinds of analysis of, and what's very nice to know is what's actually out there. So if you have a service call, what's been already done to that machine, who did it, all this kind of things are easy then to track, see, before you go out and service that machine, as an example. So I think Neo4j will give a lot more examples later, but that's just one that kind of stuck with me for my time at Caterpillar. Oops, I don't need to erase this. I can just kind of move on. Another thing to note is when you talk about graph technology is these different providers, and in this case you'll hear a little bit from Neo4j, they have a graph database technology, but then they also surround that with additional services or components that come with the platform. For example, you can see the little nodes here that happen, all these relationships that are there, there's a thing that's an explorer kind of thing. Think about it that way. To look at the data in a graphical way that kind of you can go and kind of see this relationship view of the data is a standard thing that will be provided by the platform. Then additional things might be developer tools. How do I incorporate the information that can get out of here into an application? So developer tool sets to build your own little apps that then leverage the graph database on top of whatever other database you're leveraging. Then there is obviously you want reporting off of this. There's you'll have some sort of a query editor or something like that where you can then create your own reports off of this graph database. And then we get more sophisticated. There are these data science toolkit. So again, there's standard, and Neo4j will talk about this, of kind of different things you see when you see things in terms of relationship, that there are certain parts of that network that have certain characteristics to point out that, again, these data science kits can identify those specific nodes or where those things are occurring, or they can basically see patterns out of these relationships that are commonly used, that give insights for social media companies, or often people want to know about what their customers are doing and what relationship they have, or again, they're more sophisticated and going as far as using ML and AI to do serious data science and uncover patterns that tell you something then within your graph database. And then last but not least, you're going to have some sort of connector, right? Somehow the data that you have has to get into this graph database, so then you can add the relationships and all these kind of things. How do you get that data there? That's typically done through connectors. So the important part here is that if you want to use graph database, understand who you're partnering with and what does their entire platform look like in terms of ecosystem and things they have, because these things are going to be what make your life a lot easier in leveraging this technology, right? The plain technology, it gets you something, but these tools around it really make it then digestible by your user community or your programmers and so on. So it's very important that you look at the entire platform as you start thinking about who do you want to partner with to leverage this kind of technology. The last thing I wanted to talk about before I hand it to Neo4j is going to have far better examples and explain this technology more to you, is how does it fit in the data warehousing strategy. So in one of my speeches that's linked in my website, it was a conference I presented to on data warehousing strategy. I'm not going to go through all that, but just quickly how this fits in. Typically the way my very high level view of how you should set up a data warehouse nowadays is you have these sources of information, right? And they the sources of information, they feed some sort of a lake. This is my lake drawing, where you dump the raw data in. You basically extract and load it. You don't transform it. So all the raw data is in here. You might then have a clean lake and a dirty lake. I won't get into that. You go listen to my talk. And then you have some sort of a more structured data warehouse on top of it. Hopefully some data warehouse as a service tool, and this is a lake in the cloud. But again, detail you can listen to in that presentation. But this then puts some sort of, so this is kind of the raw data. This then is your business data, whatever this really is the data that, it's in a format that people understand it, they know where it is. You got extra things on here to do data cataloging and so on, but in here it's your they have definition of standard KPI. It does all the math for you to transform this into the KPI that then, again, after that, users can access this information and use BI tools, maybe APIs to get to the data, whatever, to access this data. And what happens here is you're going to leverage something like this. So basically these connectors, you want to connect to, these things here. That's then the connectors. And then here's your graph platform that sits on top of that. Okay, so you pull the data in, and then you can augment it with the relationships and so on, and then the graph platform allows you to do the things that they're good at, which is all these scenarios that rely on relationships. So that's kind of how it's structured. It's basically another platform that sits just like these on top of your data warehouse, pulls in data, and then does its magic. So that's how it fits into your story. What I would avoid is, unless you're experimenting, doing something just for a short period of time, don't pull from here. Pull from here. Don't go to each app and pull it in. And it's so much better if you have a data warehouse to pull this data in from. You have data quality routines in here or something, that the data is clean and all this kind of stuff. That's really how it should fit into your data warehousing strategy, in my perspective. And that's all I had to share, I'm pretty sure, because I'm going to hand it over to the Neo4j guys now. And have fun with them. And they'll give you a lot more specifics and be able to answer the difficult questions. Hi, it's Volker again. Unfortunately, I realized I put the wrong microphone on when I taped the session of Neo4j, so I'm going to try to do it a little bit of justice and share their content real quick. And again, if you want to reach out to them, here are the folks from Neo4j. They're pretty easy to find. Okay. I think Stefan started with this equation, which is how the whole thing started, and some sort of math around, I think the edges, the connectors, but I don't recall. Again, he then walked through pretty quickly some, powerful use cases they've had, and quizzed us on which company this probably was, and obviously you'll see there's some impressive companies that use graph technology for these relationship kind of analyses. So again, one is person-to-person connections and friend of. So this is obviously Facebook, and now called Meta. I think we talked about that briefly too. But obviously being able to do these networks that relate to relationships of people is incredibly powerful for these social people kind of internet companies. Then you often have, person can follow another person. So again, that's another form of relationship, and you can see how then the analysis around the relationships starts getting really interesting for companies like this. Who's got how many followers, who do they follow? If I know this person, maybe their followers are interested in my product, etc. You can think of all kinds of scenarios why the relationships are so incredibly important in these people networks. Drives, that looks to me like Lyft, Uber, whatever. Again, important analysis around who's driving whom, and things you can then do around analysis of drivers or people that use the driving service. Search, this is this is Google. I think Google was one of the first or early adopters of this kind of stuff, which allows people to search and what were people searching, and then the relationship between the person and the things they're interested in, to then obviously do the advertising part where these are the things that this person is interested in. Again, you can think of more scenarios, but that's kind of an obvious one. So again, then This equation, I think, is the way to identify influencers. So again, in this diagram, you can see the B person is very popular, but through that popularity, C, who's a good friend of B maybe, or knows B pretty well, gains in popularity. And again, you can think of all kinds of ways to understand, oh, here's a great influencer. That's somebody who, people might want to advertise through, as an example. Or again, you can think of 1,000 scenarios, but again, this analysis of the different roles people play in the network is interesting. So you see again, there's all kinds of examples of E could be somebody that's a gateway to B, although there's a lot of these little guys that also directly connect with B, but E seems to have sort of a subset of B. And again, you can do all kinds of analysis on that relationship. And then it was interesting, you talked about some of the different nodes and what they are. So again, these are, then you can do, remember earlier I mentioned in the graph database platform, you have these additional tool sets around analytics and so on that allow you to define these kind of nodes in the network that might represent a certain thing or having a certain importance. So Stefan started walking through, D has the highest valence, so this is the most connected individual. So again, you can then, with these graph platforms, you can figure out who are the D's in our network, who are these highest valence people. The G is the highest closeness centrality, which means information through those people will spread the fastest through the network. So centrality is another thing you can use these analytics to find who are these centrality players in the network. Node is obviously the highest betweenness in terms of centrality, and then they are obviously the connectors of two groups, right? If I doesn't get informed from the right or the left, the other group doesn't hear about it, as an example. So again, they're important nodes in the network to know about, not just for social media. I think Stefan gave the example of, hey, failure points, right? Let's say you're talking about logistics, transportation. If I goes down, everything from the right never gets to the left. So these are important nodes then to make sure they're functioning. Okay, so again, all kinds of analysis you can do with these networks and these relationships that add, I think, immense value to many scenarios within a company. And again, this was briefly how this fits in your portfolio. So again, I think the stress here is that they're extremely agnostic. You can do on any cloud platform. You can ingest from any system, and then you're ready to graph. So these connectors are the ingestion. The connectors, again, we talked about earlier as part of a typical graph platform. And they all sit on whatever either on-prem infrastructure or cloud provider you have. And it's unstructured or structured data. You then connect, and then you start building these data relationships within your graph database. And then you basically are augmenting your data that you have with this graph information to then provide these new insights. So I don't know if you remember earlier in my section, I talked about the typical data warehousing strategy, and this pretty much reflects that you load this. I had some comments on how you want to get actually things to then get into this database. I wouldn't go directly to the apps, but again, that is an option. I'm not saying it's always wrong, but I'd tie it more to a data warehousing strategy, and then basically have this platform be a capability on your data warehousing platform around graph technology. Then Andy stepped in and gave some examples. I think Meredith was all around, I don't remember the scenarios so well, but I'll summarize, and this was clearly taking advantage of, I think, people networks, that help them improve web traffic and hits on there, and obviously sales of their product, because they knew a lot more targeted of who to go after in, using those analyses that I just showed earlier in what these different important players are and nodes are within your network, and then taking advantage of that to better target. And they had some, I know, impressive statistics of uplift that Meredith achieved through that. And then more for the manufacturing folks, he talked about Lockheed Martin's bill of material graph, and he gave a satellite example for them, and these products take a very long time to get to market, and they have a lot of steps and a lot of dependencies on vendors, and knowing again throughout that network on who supplies what and all this. They had invested a lot of money in traditional databases to try to manage basically the end-to-end supply chain of that bill of material for the satellites, and spend lots of money. And when they started drawing out what they needed, it became very clear it was more of a relationship network of components, parts, vendors, that was important to them in terms of optimizing their manufacturing supply chain of these satellites. So they then turned to graph technology to make that happen. And then again, graph data science is again this ability to then, on top of the data you have, to understand the data and they then have standard formulas, logic, I don't know what the right word is, to find and identify these patterns within your network data, or your relationship data, graph data, that allows you then to quickly find these opportunity areas, which again, if you were to pull up one of these graphs, a human, the net, if they have millions of connections and nodes, and it's impossible for humans to really find the nuggets in there. And that's what the graph data science on top of these platforms provides you. So again, to my earlier topic, it's important that you look at the person you partner with, the entire platform they have, and what they have in additional tools versus the core technology of a graph database. And I think that was it. So sorry I didn't get, obviously Stefan and Andy did a far better job than me, but I promised to get this out to all of you, so I did the best I could. Okay, thanks.